We tend to think that the world is very large and that we can do within it what we want, and that biology and biophysics and the biosphere will continue to work as it has in the past, that it's large and substantially immune to disturbance. That is absolutely not true. It's being disturbed at the moment. The fact that the Earth is warming as a result of human activities is a really terrifying fact.
So we look at some a little bit more sophisticated model than just a straight line, which I showed before, for the entire northern hemisphere and permafrost temperature and distribution. And this model used kind of moderate climate warming scenario. It was from the previous IPCC. It's A1B, so it's kind of about probably 4.5 scenario. So it's not the worst, almost the best actually. And what we can see by 2050, according to this climate scenario, permafrost, all this red is permafrost is thawing. It's already gone from the surface. It's somewhere still maybe deeper, but few meters from the surface down, there is no permafrost already by 2050. So by the end of the century, well, about half of permafrost will be thawing, and that's moderate scenario. And even this kind of green, the blue areas, it looks like it's safe and stable. Well, it's not, because in these blue areas, there will be increase in summer thaw. And this increase in summer thaw will get into ice and develop some processes which are not reflected in this model, like thermokarst, thermal erosion, slumps, and so many things which actually can produce some sudden changes in permafrost, sudden thaw of permafrost. And that's, it'll be in many places in that blue area. So blue area is not safe either. Now, the same model can be used just to illustrate what we can imagine, what we can aim for in terms of warming. So 1 degree of warming in the Arctic, I'm talking about Arctic warming, not global, will start thawing permafrost in this rim, southern rims around the permafrost area. So 2 degrees warming, and 3 degrees warming, and 4 degrees warming, and 5, and probably that's what will be kind of realistic for that Paris Agreement, about 6 degree warming. So that's what will happen to permafrost if all these problems and obstacles Paris Agreement will be implemented. Permafrost, well, it will not help too much to keep permafrost at the base. So half of permafrost area will see thawing of permafrost with all these consequences.
Whether we can do 2 degrees without carbon capture and storage, if we look at the IPCC Working Group 3 scenarios from the 5th assessment report, 87% of all the scenarios that are consistent with a 2 degree warming use negative emissions of some sort. By negative emissions, we mean greenhouse gas removal, so removing greenhouse gases from the atmosphere. Most of those scenarios use bioenergy with carbon capture and storage. So carbon capture and storage is central to many of the projected pathways to reach 2 degrees Celsius. And not only this, carbon capture and storage is not only an important technology for BECCS, but if we're thinking about the continued use of fossil fuels, as we phase out fossil fuels, we're probably going to have fossil fuels in the mix in 2030, still a fair proportion in the 2030, and going out to 2050 as we begin to phase fossil fuels out, there's still going to be some fossil fuels in the energy mix. So given the fact that they're going to be there, it seems ridiculous to me that we wouldn't try to use carbon capture and storage to prevent some of that CO2 going into the atmosphere. So whether you believe in large-scale bioenergy with carbon capture and storage, or whether you think that we should be phasing out fossil fuels more rapidly, in my opinion, we need carbon capture and storage to reduce those impacts. And indeed, the excellent paper by McGlade and Eakins in Nature in 2015 shows that without carbon capture and storage, then we are in serious trouble.
The real wild card is the third one. Hydrates, gas hydrates, and free gas below permafrost. That's a big risk, very unknown risk, but potentially very, very serious. So, but there's some new phenomena. New phenomena, it's those craters, which are actually could be the conduits of methane from below the permafrost into the atmosphere. And well, I don't have too much time. I will just show some slides just to impress you, and if you have questions, I will explain. So there's several of them just suddenly appeared in the Yamal Peninsula about 2 or 3 years ago, and it's about 30 meters in diameter and 50 meters deep. Look like this and wall. It was actually erupted, those things, and pieces of dirt was thrown by 100 meters away from the crater. So it was huge pressure in this thing, which followed down. And now in the winter, people get into it, and that's how it looks like. It's already half filled with water during the summer, and that's interesting thing. So when they discovered this hole, they measured methane concentration in the first summer after it happened, and it was 6%. 6% of methane was on the bottom of the hole. So it is related somehow to methane, and it could be a source. Of course, if it just fueled them, they're no worry, but we don't know. Maybe they will became very, very common. So now there's some, at least 7 of them was happened. 7 in West Siberia on the north. It's on the map here in the red dots. And what is interesting that before it looks like a small pingo. I don't know if you know what pingo means, but it's kind of hill about 40, 50 meters in diameter, 10 meters high. And then, see, this is very high resolution images. So that was right before, well, in 2010. So, and then in fall of 2013, it's erupted, developing a crater. So that's kind of remote sensing pictures of that. And by now, after all time, it's just became a lake. So this is the latest images, here. Yeah, this is the latest from the last summer, and it's just lake. And we have hundreds of thousands of lakes there. So maybe some of them really this kind of origin. Yeah, it surprised me definitely, and it surprised. Oh, the question was if this new estimates of degradation of permafrost it surprised me. Pretty much, it's short, yeah. And I start to answer, yes. It surprised other people as well. It surprised them so much that they don't believe in that. And even permafrost scientists, they would say, well, no, it's impossible. Permafrost on the North Slope will not start to thaw anytime this century. But this, being more realistic, well, if you can say this, more realistic about climate scenarios, but at least range of them, we see that at some range, like more like 8.5, for example, scenario, will start thawing permafrost on the North Slope of Alaska, and it will be happening at least at the half of the area of the North Slope. So it is very surprising.
We tend to think that the world is very large and that we can do within it what we want, and that biology and biophysics and the biosphere will continue to work. The fact that the Earth is warming as a result of human activities is a really terrifying fact.
So we look at some a little bit more sophisticated model than just a straight line, which I showed before, for the entire northern hemisphere and permafrost temperature and distribution. And this model used kind of moderate climate warming scenario. It was from the previous IPCC, it's A1B, so it's kind of about probably 4.5.
As it has in the past, that it's large and substantially immune to disturbance. That is absolutely not true. It's being disturbed at the moment.